Good afternoon, colleagues. Good afternoon, engineering practitioners and built environment leaders. On behalf of Consulting Engineers South Africa, CESA, your partner in enabling consulting engineering excellence, I would like to warmly welcome you to today's session. My name is Godfrey Ramarisa. I am Stakeholder Liaison Manager here at CESA, and I will be your Program Director for this afternoon session. So today's topic, Engineering a Greener Future and Navigating Decarbonization Strategies in the Road Infrastructure. So this topic aligns strongly with the mandate of the Quality, Risk and Sustainable Management Committee, particularly in advancing responsible engineering and climate responsive infrastructure, which is risk informed. So as consulting engineers, you are at the forefront of addressing climate change and carbon reduction targets. You are in the forefront of sustainable materials and design choices. You are in the forefront of long-term infrastructure resilience and delivering public value with managing risk and finite resources. So road infrastructure remains a critical area where decarbonization and sustainable interventions can be achieved. Our guest speaker today, and thanks a lot for agreeing to participate as our guest speaker. It is Mahendren Manicum, who is also member of the Quality and Risk Sustainable Management Committee of CESA. He is also the Managing Director of Naidu Consulting, and he is a fellow to both South African Institute of Civil Engineering, SAICI, and the Society for Asphalt Technology. Mahendren brings extensive experience in pavement engineering, asphalt technology, and sustainable road infrastructure solutions. His strong practical expertise and leadership in decarbonization strategies and sustainable infrastructure delivery position him at the forefront of industry innovation. As a visionary leader and widely recognized expert in pavement engineering and sustainable practices, Mahendren is pioneering the integration of climate change mitigation and adoption into infrastructure planning. His forward-thinking work includes developing climate resilient strategies, advising on policy frameworks, and applying advanced financial models to reduce carbon emission while protecting infrastructure against the impacts of global warming. So in recognition of his commitment to innovation and excellence, Mahendren has received international acclaim as a member of the prestigious FIDIC Top 100 Global Leaders Forum. Mahendren, thank you for joining us today, and you are most welcome. So without further delay, I invite Mahendren to present on this topic of sustainability, which we expanded by saying it's engineering a greener future and navigating decarbonization strategies in road infrastructure. Mahendren, thank you very much. Over to you.
Good afternoon, colleagues. Thank you, Godfrey, for that long introduction. It's a very kind introduction and very generous of you. So thank you very much.
I think I omitted to say that you are a professional engineering technologist.
Okay. No, it's okay. So I would like to extend my gratitude to CESA for the opportunity to present today, I think on a very critical and current worldwide crisis, climate change. So today, I would like to address the 5 critical climate change pillars in my view. And the first is to understand the effects of climate change. And I'll do that through a short video, which Hopefully you will be able to see clearly. We had a few glitches early on, but I'm sure that's ironed out right now. Then we'll talk about the legislative framework that governs the context in South Africa. So what is the legal context of how climate change is governed in South Africa, and then linkages to the International Paris Agreement and Accord. We look at climate mitigation strategies, and then we'll apply climate adaptation strategies. How do you apply adaptation strategies in a real practical sense? Towards the end, we'll develop a climate change roadmap of where we believe the country should go to in order to expedite the reduction of carbon emissions, and then obviously reduce our carbon temperatures to well below 1.5 degrees. And then I'll conclude with some concluding remarks. So I would like to start by sharing a brief video. Thank you.
Right now, we're facing a man-made disaster of global scale, our greatest threat in thousands of years, climate change. If we don't take action, the collapse of our civilizations and the extinction of much of the natural world is on the horizon. The world's people have spoken. Their message is clear. Time is running out.
The amount of carbon dioxide in the atmosphere now is 50% higher than it was in 1900. And not only are we piling in more and more carbon dioxide in the atmosphere, but we are chopping down the forests of the earth at a great rate. And the forests themselves are the most efficient consumers of carbon dioxide that there are on Earth. We're going to destroy the ground because the soil of a rainforest isn't very good. We are actually tampering with the climate of the Earth and with the very atmosphere that we breathe. When we talk about the disappearance of the ozone layer, we don't know what will happen when the ozone layer goes. The world has become so fragile that we cannot subject the Earth to the tortures we can now inflict upon it. When we talk about the greenhouse effect, we're talking about something that affects the entire Earth. And these problems are life and death problems. They go to the root of the viability of the planet itself. If there's one thing that is biologically certain about the human species, is that it is a human species, one species.
If we don't stop the destruction of our natural world, nothing else will matter. Simply put, if we don't protect nature, we can't protect ourselves.
The only way we can solve a problem is by a human solution. Never can we sit back and wait for miracles to save us. Miracles don't happen. Sweat happens. Efforts happens. Thought happens.
So guys, what did we just witness there is total devastation of our polar caps disappearing, glaciers melting, sea levels rising, and forests being destroyed. And if that's not awakening a sense of disaster in your minds, and I don't know what will. So it's just crazy how humankind is destroying the world. And hopefully this session with you today would bring some sense back into the way as engineers we plan, design, construct, and monitor and evaluate through our project life cycles. So the next slide is a real depiction of increasing temperatures over time. And you can see at the 1900s, during the first industrial revolution, the globe slowly starting to warm up. And then as we get to the 1970s and 1990s, it starts to increase even further towards 2010. And we are well now into 2026, and you can see the heat being incubated through the greenhouse effect. By 2026, we are well over the 1.5 degrees that we need to cover by in terms of the Paris Agreement. I think simply put, climate change is primarily driven by the emissions of greenhouse gases, such as carbon dioxide and methane into the Earth's atmosphere. These gases trap heat and lead to an overall warming of the planet, a phenomenon known as the greenhouse effect. So as Earth temperatures rise, it disrupts the delicate balance of atmospheric and oceanic circulation. So these patterns give rise to more frequent and severe weather events. I mean, in 2023, in the Western Cape floods, the Cape province was struck by unprecedented ferocity, leading to loss of life, displacement of communities, and extensive damage to property and infrastructure. The torrential rains overwhelmed drainage systems and rivers, exacerbating the disaster. In 2022, parts of KwaZulu-Natal experienced devastating floods that left a trail of destruction and tragedy in the wake. These floods, driven by a combination of heavy rainfall and inadequate infrastructure, demonstrated the severe impact of climate change on vulnerable regions. Tragically, 459 people lost their lives in these devastating floods. One of the most troubling aspects of these recent floods in Limpopo was the impact on vulnerable communities, the communities that suffer the most. 46 people lost their lives, their homes, their possessions, and livelihoods. The floods disrupted access to clean water, food, healthcare, posing serious humanitarian challenges. I mean, these catastrophes underscore the importance of global action and the cooperation to mitigate the root causes of such disasters and protect vulnerable regions from the devastating consequences of climate change. And I'm sure some of you in this room or online, rather, is sharing firsthand the devastation that should have affected your families. And it's quite disheartening to see that we need to do much more to prevent these disasters. Okay, some alarming facts. South Africa is the 14th largest contributor of greenhouse gases in the world. South Africa is also the largest contributor of greenhouse gases on the African continent. Our mean annual temperature in South Africa increased by twice the global average at 0.7 degrees. To date, approximately 50 billion rand in infrastructure damages has been incurred during climate change events. So if we look at it, by just investing a small fraction of these costs into mitigation and adaptation strategies, we can minimize these huge losses to our economy. When I gave a talk at PIAC in December, the weather services warned the country of the onset of El Nino. So it's a cold front that comes in. So El Nino is a little girl, and El Nino is the boy, which is a warm current that comes in. So they warned that there'll be intensified rainfalls in December and January, which actually happened, particularly in Limpopo, which could face flooding. And it happened. And yet, through all these early warning systems, we could not save, we could not limit the cost of lives, and 46 people lost their lives, and many of them were innocent children. So what happens at 2 degrees? So we have to limit the temperature increase, which is in terms of the Paris Agreement, which I'll talk about later, to 1.5 degrees. But what happens when you move to 2 degrees, which currently is the case because we actually move from 1.5 and we're moving towards 2, In 2018, the Intergovernment Panel on Climate Change, which is the IPCC, released a special report that drew a comparison between the effects of global warming at 1.5 degrees and that of 2 degrees. They concluded that anthropogenic activities have already caused a 1 degree warming, which we all know. And that when this warming, which is now likely to reach 2 degrees, the devastation will be catastrophic. You'll get intense heat waves, which will last a third longer. Droughts as well as heavy precipitation would be a third more intense. An additional 10 centimeter rise in sea levels, we saw it on the video, and also create rapid melting of glaciers. The polar caps, destruction of ecosystems and coral reefs. So mostly irreversible changes will be witnessed. So, good people, we have to act now to make radical changes in order to prevent the rise to 2 degrees. South Africa, for me, has one of the best legislation in the world. I mean, we talk from our constitution and we work all the way down. So we are very, very strongly regulated against climate change. And let me tell you what we're going to do about this. So at the heart of South Africa's approach is the National Development Plan. Okay, it's a strategic framework aimed at addressing the country's key challenges. One of the core priorities is the promotion of a low carbon economy. The National Development Plan was developed in 2012. And even in that time, our government had a foresight of acknowledging climate changes and the changes to atmospheric pressures and the increase in temperatures. The Paris Agreement in 2015 was signed by 196 countries, as I said, which aims at limiting global warming to below 2 degrees. We looked at the first 1.5 degree mark, which we did not make, and now we are trying to limit it to 2. I've just shown you, if we don't limit it to 2, the catastrophic events that could happen should be not limited to 2. Catastrophic events. The National Development Plan led to the development of the Carbon Tax Act. Now, the Carbon Tax Act, we all know when we buy new vehicles, you have to pay a Carbon Tax Act because the country is trying to limit the amount of emissions into the atmosphere. With the geopolitical climate that we have right now, with the war in Iran and Israel and Ukraine and Russia, we slowly finding very quickly hurting our pockets is the cost of fuel. And therefore, you find that EV vehicles are being sold more often. And as a mitigation to climate impacts and CO2 emissions, that's one of the areas people can look towards is electric vehicles. Further strengthening the commitment to climate change is the Climate Change Act, which both talks about mitigation and adaptation strategies. In August this year, the climate regulations accompanying the Climate Change Act was published, offering guidance on the determining carbon budgets for various sectors. At the recent Presidential Climate Commission meeting, it was proposed that we limit our CO2 equivalent targets or budgets to 380 megatons by 2035. So with our carbon budgets that the country has submitted to the IPCC, we have to report on a quarterly basis to the IPCC in terms of how we are limiting our carbon budgets to the acceptable limits as agreed to in the Paris Agreement. You'll soon see with the Department of Fisheries and Forestries and Environment, each industry should be getting their carbon budgets, and then we need to then act towards it through policy directives in the instance of Department of Transport, through the Green Transport Strategy or the National Transport Plan, which talks about how we're going to actually sectorize our carbon budgets. But importantly, and what people forget, encompassing all these acts is a framework called the Just Transition Strategy, which ensures that socioeconomic impacts on all stakeholders are carefully considered. I think this strategy is facilitated by the Presidential Climate Commission, ensuring that the transition is both inclusive and equitable. You can't have a situation where you enforce these massive changes on the rural poor and expect them to accept it. You can't expect to tell a rural community that you're building half a road towards a clinic because the impacts of climate change is going to take effect. Those poor people have been waiting for 60, 100 years for a road, and yet you come in with the first world policy. So this is a dilemma that we face in the country: is how do we as a developing country or a developing country construct roads, but do it in a more greener manner? And we'll discuss ideas around that as we move on. The question is, are we ready for this? Now, the Climate Change Act is very clear in sections 8, 9, and 12. It mandates SOEs, provinces, and municipalities to develop and implement mitigation and adaptation strategies, and also to look at areas of vulnerability. Now, we'll discuss all that later on through my presentation. But it's an onus on these organs of state to ensure that we prepare. If we can't mitigate, then we adapt to ensure that our infrastructure is resilient to the effects of climate change. So let's start with climate mitigation. And I think we first need to understand what's climate mitigation, and then we'll talk about adaptation. So mitigation is around how do we mitigate the curbing of actual CO2 emissions into the atmosphere. Okay, so how do we ensure that we reduce and prevent the emissions of greenhouse gases that drive climate change, which includes strategies such as switching to renewable energy, which we as a government are really trying towards, solar and wind farms, improving energy efficiency in a similar fashion, and protecting forests that absorb carbon dioxide. So those are some of the areas that we need to look towards. The other huge mitigation factor is obviously through the Integrated Resource Plan, which is developed by the Minister of Minerals and Energy, that look at how do we slowly reduce our coal-fired plants that provide us with electricity, which is Eskom. I mean, that is one of the largest contributors to greenhouse gases in the country. So the Integrated Resource Plan is actually showing that through time, we will be reducing those effects. But my next illustration is a tool that aligns the ISO 21930 template, which is basically the ISO governing climate change. And then how does it integrate into PAS 2080? PAS 2080 is a document, a very good document written by the British government that talks about climate change. So it starts with basically policy and procurement and stakeholder engagement, where you'll have the different phases through construction. So in terms of the structure, it becomes critically important that the asset owners, which is basically the policymakers, and they are government, okay, which writes the rules of the game, writes the law, together with the designers, which is the engineers, contractors, suppliers, that we have to form a coordinated response to deliver on these mitigation strategies. It has to be a collaboration. So carbon accountability must be integrated at every stage of infrastructure delivery, from the design through construction, operation, and the end of life stage. And that's depicted in the illustration that you see in front of you. I said the public sector must lead by revising, for example, COTO specifications, design standards, manuals, and public procurement frameworks to embed carbon reduction as a core project requirement. Then we start reducing and mitigating against CO2 emissions. With the national carbon budget now proposed at 380 megatons for up until 2035, the recent promulgated Climate Change Act and regulations, both government and industry are required to define and implement sector-specific carbon budgets in line with South Africa's nationally determined contribution. So the nationally determined contribution is our budget, which is 380. So at the planning and design stage, in the illustration, a circular economy approach must be embedded in infrastructure design, supported by robust tools such as your LCA, is your life cycle cost assessment of what is the life cycle cost assessment of carbon, and then your LCCA, which is your life cycle cost analysis, which is quantifying the cost of using new methods, which may cost initially higher, but in the long term produces a more resilient outcome and prevents meaningful target contribution towards our NDC. At the production stage, our suppliers play a critical role in supporting decarbonization efforts. By example, your bitumen plant manufacturers should be encouraged to set clear targets for reducing their carbon emissions. I mean, this includes, and Sabita is going to lead on this, the introduction of product category rules, your PCRs, and environmental product declaration forms, your EPDs, to ensure transparency and standardization in measuring environmental impacts. I've said organizations such as Sabita have already taken steps in this direction by developing a carbon calculator to quantify emissions which are associated with asphalt plant manufacturers. Tools like these are essential for enabling more accurate life cycle assessments, which I've just spoken to you about. Now, if you limit your plant by using green technology, wrapping it up in blankets, using gas instead of electricity, those are massive reductions and mitigate towards your increase in temperatures. At the construction stage, the implementation of material management plans, along with low carbon construction strategies and the adoption of smart technologies, is essential for improving resource efficiency and reducing environmental impacts. These approaches should be supported by the quantification of CO2 emissions to track progress and inform data-driven decisions throughout the construction life cycle. The use stage. This includes the adoption of solutions such as warm mix asphalt. If you look at the Netherlands and Germany and European standards, in 2030, all roads will have to be constructed using warm mix asphalt. You cannot apply hot mix asphalt. Hot mix asphalt is produced at temperatures in greater than 200 degrees Celsius sometimes. Warm mix asphalt is down to 90 degrees. You're reducing your energy by half. You're reducing your electricity usage by half. It's a big step in the right direction. The use of long life pavements, integrated asset management systems, and also early warning systems that predict when a bridge will be struck, for example, by heavy rains or destruction that will happen with your road network in low-lying areas. These enhance climate resilience and reduce the carbon footprint of infrastructure. Because remember, if you come back and rebuild those roads, you are just emitting carbon emissions where you could have built it right the first time, using resilience and adopting standards that are making your road and the surrounding areas more robust and more resilient towards climate change. Then you go to the end of life stage, focusing on circularity, which means circular economy. How do you reuse, recycle, rework, and also your resource recovery to the end of your asset's life cycle, reducing waste and supporting a more sustainable built environment. So that's your end of life. So we talked about mitigation, and mitigation is actually the true reduction of CO2 emissions into the atmosphere. Okay. So like right now, we are not doing enough for mitigation. We have to look at the areas of how then do we adapt. So you can't mitigate, or you're trying as best as you can to mitigate. But look, you can see the catastrophic events before us in South Africa. We can see what happens when the temperatures continue to rise. These catastrophic events. I'm sitting here in Durban now in April, mid-April, and it's 32 degrees and hot and humid. You know, these are unprecedented times, which I've never experienced before. Now, so if you can't mitigate, you have to adapt. So climate adaptation refers to, so there's mitigation and adaptation. Climate adaptation refers to adjustments in natural or human systems to reduce the harm caused by the impacts of climate change. So it involves actions such as building flood defenses, developing drought-resistant crops, improving water management. These are some of the areas. The goal of adaptation is to increase resilience and cope with current and future climate-related changes. So you're going to start being agile and adapting to these floods, adapting to intensity of rain storms, more fires and drought, things like that. So this is what we'll try to show you. So, you know, I think internationally the facts are clear. We are not on track to limit temperatures to 1.5 degrees. The key question is that if we're failing to mitigate, as I said, how do we adapt to these escalation climate events? So before I introduce to you the vulnerability assessment and adaptation tool, which I promised, let me discuss some of the stresses. Now, when you talk about climate and resilience and you talk to all the clever professors, they talk about stresses. So it's a new terminology, stresses. So what are the climate stresses that actually affect us more in South Africa? So a common one is this increase in temperature resulting in heat waves. Then we have increase in rainfall resulting in flooding. The other stress is decrease in rainfall resulting in drought. Decrease in temperature resulting in snowfall. I mean, we had the snowfall in Nottingham Road. It closed the N2 down for almost 5 days. That caused huge economic stress in the areas in Durban, Pietermaritzburg, and also in the country because you couldn't get our goods and freight to the port. You couldn't export. We lost millions and billions of rands. Sea level rising. You find a lot of sea level rising on the coastal areas in Eastern Cape, especially the Western Cape. You have coastal flooding. Wildfires. We saw that in Cape Town because of dryness, drought areas. You have wildfires. How do you adapt for that? Erosion. Excessive rains, cut banks very steep. You have massive erosion. You look at Cape Town and the mountainous terrains and the passes, always closed because of rockfall. And then you have these massive winds that actually you have to shut down roads, especially in the Eastern Cape and the Western Cape. So those are some of our stresses that uh, we are faced with. Now, on your vulnerability assessment and adaptation model, this is called the VAF model. Now, it's a model that is very easily used and can be adopted. It's adopted from the federal highways in the US, and we just adopted it to suit the needs for explanation of what I think this model can achieve in South Africa. So, by incorporating models like the vulnerability assessment adaptation framework, we are be able to and prioritize climate risks at both a national and a regional level. And I think that's how we need to look at it and package it in terms of vulnerability. This model will guide the planning and design process, helping stakeholders identify and respond to the most critical vulnerabilities. The adaptation measures require clearly defined scope and measurable objectives, and that's your first part of this framework. This must be approached through a coordinated, integrated strategy at both program and project level. So it's basically national, regional, program, and project. One of the critical enablers will be to integrate climate variables and data. I mean, that's a key source. And you can work with the South African Weather Services. There's the CSR Green Book, which I'll talk to just now, which basically informs infrastructure planning and risk management. Then you will have to compile this data, compilation of data using an as-built information from your asset register. That's becoming more and more important in terms of your planning. And then developing guidelines from inputs with CSR, I just spoke to you about in the Green Book. You then look at you then assess vulnerability. Now, vulnerability assessment involves incorporating stakeholder input. And a lot of this is often forgotten when you actually go to stakeholders and you ask them when was the latest storm that hit, or the fire, the devastation, the intensity, how long it is. Those are important parameters to determine how you'll adapt to that specific area. And then this process is supported by an engineered informed approach. Okay. So using stress assessment visualization forms to ensure that technical evaluations are grounded in real world risks and conditions. And now we get into the integrated decision making scenario. So you then analyze your adaptation options through an economic analysis and multi-criteria analysis using your LCA and LCCA calculations, which I briefly explained to you early on. This information provides a solid grounding for decision-making processes in terms of project prioritization and adaptation strategies. So that will inform you which is the worst areas and when and how we must adapt to ensure that the roads or bridges or structures or buildings are well surrounded to prevent this catastrophic event. Okay, and then these are just some of the adaptation strategies. Like I've talked about, this is basically how the green book looks. So you get this information from CSR. It'll show you the extreme rainfall days, and then through that you can, if you have a predictive modeling scenario within your offices, you can look at rainfall days and exposure to flooding. This is an example. Then the adaptation action strategy, which is a stress assessment. I mean, we use this as a TMH9 methodology. It involves evaluating climate-related stresses through a systematic field-based approach. So it's much like using a TMH9 guideline. And we use it in every 200 meters intervals. For example, if you look at the indicator, which is erodibility, we then find what is the degree and what is the extent. And the stresses are precipitation, temperature, wind, drought, fire. So that's on the left-hand side column. And at every 200-meter intervals, you give it a degree and extent. And by doing that, you look at intervals of classification and then your degree and extent to get a value. Coupled with that is then your matrix on the severity and the frequency of the event. So how frequent it happened, but how intense it was. And those parameters enables a consistent quantifiable assessment of vulnerability across infrastructure assets, forming a basis for prioritization and adaptation planning. So what then, from using your VAF model, from using your data inputs in asset management and your vulnerability assessments and your stress assessments, how then do you adapt through the various stresses like drought, flooding, wildfires, snow, storms? How would you adapt? So for drought, and these are practical examples, you can implement a solution to prevent drying of materials in fills and subgrades, which could lead to shrinkage problems. Flooding, use nanomaterials. I mean, nanosalines are widely used in the industry right now with anti-stripping characteristics. So within your pavement layer or as a hydrophobic coating on the surfaces. So it coats the surfaces and prevents water ingress. So it holds your structure firm. Wildfires, your mixed designs incorporating aggregates with high thermal stability, such as binders, modified polymers, and result in higher softening points. These are simple areas of adaptation. Snowfall, propose alternative pavements with anti-stripping agents to improve durability during your freeze-thaw cycles. So let's look at EME, look at stiffer pavements, look at long-life pavements. Storms, propose free draining systems that mitigates against aquaplaning. I mean, what Sunroad is really trying out now is looking at that technology and using rubber bitumen, because that is a drain down effect and takes water out. And within the 6 millimeter variant of a road infrastructure to prevent aquaplaning, those are some of the thoughts that are coming forward in terms of saving lives and also becoming very fatigue resistant and also creating long life pavements for deformation. Heat waves. Propose modified binders that have a higher softening point and offer greater durability. And we talked about erosion. Erosion, you can use simple solutions like vertigrass. Cut your bank slope slightly flatter, 1-in-2 instead of a 1-in-1 slope. But also use natural resources as a mitigation measure, but actually just use common sense in some of these areas. So we've been through mitigation, we've been through adaptation. So what is the way forward and where do we go from here? So if I want to summarize what I've said, I said, firstly, everyone should at a national and provincial level look at where is your greatest risks. So where are my hotspots? How do I get to where my hotspots are? I use my asset data or use the data I have. I then look at vulnerability of each asset that I have. And it's very clear in section 8, 9, and 12 of the Climate Change Act that organs of state have to do it as a matter of course. It's a requirement. And when you got your vulnerability assessment and understand where your extremities are, then you can use that to either mitigate or adapt. Now, in terms of adaptation, the next phase, obviously, when you get all that, is to be in parallel rather than a roadmap, is for a organ of state to go get in and start changing your design manuals. What are my return periods? What are my hydraulic analysis changes? How should my COTO specifications for climate change be introduced? How do I, through the project lifecycle, embed climate resilient modules in my design, in my conceptualization, and then in my execution? So I think these are clear indications of a radical change from how we normally do things in the industry. Of course, what I haven't discussed today is you have mitigation adaptation, but in more instances than not, we have to respond to a climate disaster. Now, that's a climate response system. How do we develop standard operating procedures to get people out of floods? How do we have early warning systems through the integrated management system from Sunral, the ITS system, integrated traffic management system? How do we use those inherent modules that we have to save lives? So that's the next module that we need to look at, or we are looking at, in terms of standard operating procedures for wind, snow, fire, heavy rainfall, and the stresses that face the country. And then you always have to have a monitoring and evaluation system to check the effectiveness of reducing your carbon footprint, so getting your carbon budget, and then looking at it through procurement mechanisms or through detailed carbon calculators, how you've actually contributed or by lessening the CO2 emissions to the atmosphere. How have you actually become more climate resilient to your road infrastructure, your bridges infrastructure, in terms of exposure to climate changing events? Because the M&E part is always a reflection of how you must make your system function better and where the gaps are. Good people, in conclusion, and it's been a long session, I think climate change is no longer an environmental issue. It's a construction, planning, finance, and leadership issue. Strong leadership, change management. We've seen devastation in flooded cities, failing infrastructure, and massive economic losses. We can no longer build the way we used to. Every client, consultant, contractor, and supplier has a role to play. Now more than ever, we need strong leadership, and not just from the top, but throughout the value chain. Finally, dear colleagues, what is certain is that South Africa can no longer afford reactive responses to climate-induced disasters. And what I have presented today is that through the integration of climate science, engineering best practices, and system-level planning tools through systems like the FAF model, we must design and manage infrastructure that is resilient, sustainable, and very importantly, future-fit. Thank you for your attention.
Thank you very much, Mahendren. I think we are now moving on to question and answers. Thanks for this insightful, quite technical, comprehensive presentation. It is important that we continue to look at the bigger picture and address challenges at a strategic level by embedding sustainable across all road infrastructure, whether it is the N1 to Limpopo or N3 to KwaZulu-Natal, or provincial roads like Wetkoppen next to our office here, or Church Street. I think all cities still have Church Street, unless if things have changed. Now it is time for question and answers. I didn't see many questions, but there was a comment, and I do have a few, perhaps non-technical questions. The first observation was a chart by Nirvana saying that mitigation should also focus on limiting global population growth and to reduce demand for ongoing developments or urbanization and migration of people. Any comments on that before we continue?
Do you want me to answer that?
Yes, an engineering solution for reducing population growth.
That's a tough one, right? I think that's a human science discussion, but I think it's a fair point. I mean, I think global warming is in big part overpopulation, and I think that needs to be looked at. there's always a double-edged sword, Nirvana, around. If you look at our country in particular, as a developing country, and the roads we are constructing right now, it seems to be unfair that the the first world countries have already got there and built the infrastructure and are doing very well because of the economic corridors are wide open and they are growing, while we still are getting there. But then we also got to look at how we get there in a more green manner. So it's going to be always a difficult way of how do you plan. It's a double-edged sword for us. So yeah, it's not an easy answer, but I mean, at least we have to try and think about these strategies when we do our construction and our design standards.
Okay, thank you very much, Mahendren. As problem solvers, yes, we should always respond to any problem. So the other question which I have here for you is, how do the current Department of Transport and/or SANRAL standards support the integration of sustainability and decarbonization principles across tendering, road design, construction, and maintenance?
Okay, I think that's a very good question. I think, well, right now I know that Sunral has got a research panel that's been appointed that are looking at these key areas of sustainability and decarbonization. The Koto Committee right now, in conjunction with Road Materials Committee, are busy changing standards for Koto, bringing in sustainability across the Koto's suite of documents. So that's hopefully will be completed in during this year. So there's big strides in terms of enforcing the carbon chain or decarbonization thinking within the road sphere and in government. And I think it's going to be a collaboration between Sunral and then the Department of Transport to then change our guideline manuals to enforce this new thinking. So it's there and it's coming, and we are aware of the changes that will happen, especially with the specifications and new design manuals.
Okay, so on the policy level, there is something that is coming
Yes,
through.
yes.
Maybe this one is almost like a follow-up, as I've already mentioned, Department of Transport and Sandral, and I thought maybe the other department which we should bring in is National Treasury to see their role when it comes to decarbonization. But maybe let me put it as a question in this way. Do the current National Treasury procurement and contract models sufficiently incentivize low carbon construction practices? And where do you think we could have improvements?
So another very good question. I think with the Department of Fisheries and Forestries and Environment, they're the custodians of putting the budgets together. So they will be telling the different divisions, the different government organizations, and say it's transport, that you need to limit your CO2 emissions by X amount of megatons. Okay. Then the Department of Transport will then say to industry bodies, you need to reduce it accordingly to get to our holistic carbon reduction budget. Now, once that is established, uh, we in parallel should be going to Treasury to say, okay, how do you enforce it within your supply chain management? And how do you enforce it through your procurement regime? So do you give bonuses if people reduce it further than what they required? Do you penalize people who are not reducing their carbon construction budgets to an extent? And how do we do that? So how do we bring it and either penalize or incentivize people to be thinking more greener on their projects? So I think right now, I think the biggest, one of the main contributors to greenhouse gases that we all know is our coal-fired plants that produce energy for the country at this point in time. And I think the first port of call is for try to reduce that. And then in parallel, or maybe hopefully together, we look at the other government departments in terms of the reduction. But I don't see it happening right now because we don't have our carbon budgets in place at this point in time. But the discussion has to take place.
Hey, thank you very much. And maybe a follow-up, I can't move away from National Treasury. Procurement is always an issue within the consulting engineering industry and construction. Maybe a further question will be, how can the tendering system move beyond a focus on least cost to better support sustainable outcomes? How do we achieve sustainability in road infrastructure if the appointments of both consulting engineering firms and contractors are based on basically the cheapest or the lowest cost?
Yeah,
Yeah.
that's a tough one, eh? Very tough. But I think it has to be a policy change, and unfortunately, through all these different committees that we have, the bid evaluation committee or bid adjudication committee, those structures were put in place to stop uh, tenders being issued willy-nilly. Okay, so we unfortunately use a whoop to hit our own hand in bringing all these committees in place, but it had to be done to ensure fairness and openness and transparency in terms of how we award contracts. Unfortunately, what it created is always the lowest person gets the job, which is really not what it was intended for, but it's happening because of people then going into appeal these tenders, and we have lack of service delivery, and that's definitely what has happened. How we change that mindset is going to be I mean, it's in the act. You don't have to award to the lowest. I mean, you can award to a person that will significantly reduce your long-term construction or benefit the project in the long term, but people are afraid to use it. So it's going to have to be a mindset change, uh, and getting Treasury buy-in on these major projects that you want to apply using different methods. I mean, it's in the PFMA Act, it's in the MAFMA Act that you can appoint people that are not the lowest, but there has to be proper motivation for it. And I think it must be done in conjunction with Treasury.
Yeah. I think I agree with you, and it's something that we have to resolve and and continue to advocate, let's say, for example, for a quality cost-based selection system where it is not just only the price and the preferencing that we require, but we bring some elements of experience or qualification into the equation, or even go to an extent of using a quality-based selection system. But it's something that we still have to advocate. So to continue with our discussion, I'm going to
But
bring on
I
the
think Godfrey, sorry, Godfrey,
yes.
if I could just interject, I think, Sandal has just concluded writing a very good document. It's a framework document that talks to how you deal with climate changes and its response. I think they'll be sending it out to everyone and all the municipalities very shortly. But in that, we talk about uh, changes to different legislation, because you quite rightly said these requirements for adjustment towards a climate response solution needs alignment to a different style of writing legislative requirements like PFMA, like treasury regulations, like your design standards. So it's coming in. The wheel is maybe turning a bit slower, but that's in the pipeline to address all these issues which have legal requirements against a act or a statute requirement.
Okay, thank you very much. Next question is around life cycle assessment and life cycle cost assessments. So from the road infrastructure best practice perspective, how should the life cycle assessment and the life cycle cost assessment be practically applied on road projects to reduce carbon emission over the full asset life? In particular, especially in design stage, which policies needs to be there? And I don't know if there are any targets for that now.
Yeah, so your life cycle assessment is basically around only carbon. So there are people that have developed carbon calculators. So through your design phase, you will actually know, for example, how much of carbon emissions you will emit if you have to build a kilometer of road, including the pavement layers that is required to construct that road. So And that's your first assessment, is your carbon assessment. Okay. And that talks about scope one, scope two, and scope three, which is where you're getting your materials from. What is the where is that being emitted from? What is your PCRs and EPDs when you're getting the material? Putting those putting those costs into a calculator, and then finally the construction of that, and then you get the scope three is how it comes. Where is the source? How, in what shipment is it coming from on the sea, and then you work all that out. So then you get a holistic value for your carbon emissions for that project. And say as we start developing these things, say it's 1,000 kgs to build 1 kilometer of road. But if you build it with using nanotech or using softer materials or using innovative construction techniques, and you build it at 500 kgs and only emit 500 kgs, then you benefit in the reduction of what you achieved. So that's the carbon emissions. On these LCCA, that's your life cycle cost assessment. We are referring to bringing in technology that may initially cost more. For example, if you're using an EME type of uh, road solution for higher order stiffness perpetual pavements, yes, it will cost more right now. But over the life cycle cost, over the 30-year design period, you'll find that you'll do less maintenance. It'll be more resilient to rainfall patterns if you identified it in your assessment phase. Now, that is done through the HGM4 analysis. I mean, I think people in the on here would have actually, if you're working with Sunbelt, you would have worked with HGM4. It's your calculated to look at economic analysis for whether the road is viable or not. So these things have been heard of and thought of, and it's alive now. And those are the things that we are looking forward to having discussions at every gate of your organization. So when you go to your FIPDIM and you go your gate one, your gate two, and your PG3 meetings, and you have discussions with the client, you show them, yes, initial costs are more, but over the life cycle, it will be resilient, and you go with the best solution for that area, for that vulnerability, and that stressor in terms of your climate response. Hope I explained that.
You did. It's something a bit new for some of us who are no longer practicing engineering, but thanks a lot. Um, there is a question from Tulani, and it's about roads and rail, and he's saying, what's your take about us improving and developing maybe more rail network to mitigate the vehicle gases on the roads, especially with all the trucks that are moving from Limpopo to KZN to Mpumalanga to all over the country. So that is sort of like the first part of the question. And then the other one was, he says he knows about the Vaal Aerozone and the Cape Winelands Airport, these economic zones are being built, but to support aviation industry are progressing. So what's your take? Rail, road, or we should be on air, and then we'll be able to mitigate decarbonization.
So a very good question, a very interesting question. So I think you would find if some of us we were there at the roads in Durban that you had recently at the Gallagher estate, there's a very high prioritization of the freight network. And the Minister of Transport, Barbara Creasy, has made it very clear on having 5 packages of, I think it was 5 packages where she had networks managing key areas for infrastructure for the rail. And I think part of that discussion was to actually increase freight, the network on using rail, obviously rather than using roads freight. Because the CO2 emissions, and I mean, remember, our trains are electric, so you're not using any carbon emissions. Your freight is causing a massive destruction of your pavement, overloading, stacking of trucks, major concern for road pavements, and then obviously the carbon emissions from the diesel in those trucks. So certainly, Tulani, the aim is definitely to go to freight. I think there's been great strides being made by the minister and the Department of Transport into moving that towards freight. It'll save a lot of carbon emissions, and you're quite right. That is a mitigation. That's directly mitigating against carbon emissions into the atmosphere. So that's on the cards. You also looked at the president talking about this rapid rail from Gauteng to Durban. Uh, he's been very vocal about it. I'm hoping it materializes. That will take a huge strain off the N2 N3 corridor uh, for the pavement, as well as making it much easier to drive when you're in your car, but because it'll be less accidents, I believe, in getting that through. So those are some of the things that the country is also thinking about. The Winelands Airport, I don't think it's going to be an airport for moving goods, but I saw the Val Airport this morning that they are doing it. That could be a possibility, but I haven't did the calculation of which is worse, uh, your airline gas or your airline fuel emissions or on the ground. I think that's a good question. Someone should be doing that analysis because the winelands as well will be bringing a lot of tourists in. Which is worse? I don't know. So those are good thoughts. I think we must look at it for future investigation. Thanks.
Okay, thank you. As we are about to wrap up, I think we did touch on procurement, life cycle, a bit on policy. I think one topic which we should include is skills and capacity. So here is my question. What competencies should engineers develop to effectively implement sustainability guidance, particularly in relation to our topic of today, carbon counting or climate resilient design? More so, we've referred to SANRAL, we've referred to Department of Transport, but there are other roads that are with the Gauteng or the provinces and municipalities. So what competencies should engineers develop to be prepared or to be geared up for this?
Godfrey, excellent question again. And I think the curriculum needs to change. And, I had discussions with Natal University and areas like that of you're going to have to introduce a curriculum at the university or technicon stages around climate resilience and change. So it has to be an ongoing sort of theorized, like a transportation sort of course, but it has to go through the life cycle of your uh, academic tertiary education. Okay, that's the first thing because this is not going to go away, and you have to develop material like I've done to an extent, but in more detail of how you design for resilience, right? So that's the first point, and it must happen now more than ever. We need to start introducing those modules into our engineering guidelines in terms of tertiary education. The the aspect around it's actually very sad, and you're quite right. When disasters hit, and I think I must have a webinar, or we must have a webinar around how do we assist disaster management in terms of an event after a catastrophe, is that the people that need the money most is the local municipalities. But yet the capacity there, and they even said it in the roads in Daba, is so poor that they don't have engineers in those local municipalities to actually design and add value to the solution that is greatly needed. So how we get around that, I do not know. It must be a total against mindset shift to capacitation of the local municipalities because that's where the disaster happens at that level, and then they can't respond because they don't have the money or treasury is not giving them the money because they may not know how to use it. So how do you get around that? I don't know. I remember back in the day when DBSA, the Development Bank of South Africa, when they lent money to local municipalities and even municipalities, they lent the money with them having to they lent it with people going in there. So they used to have two engineers and one finance person going in there, making sure that the money they lent to those municipalities were spent correctly and were actually building back better, future fit infrastructure. Unfortunately, that program didn't materialize the way it should, and I think we must have discussions around how do you bring back and support these poor municipalities that need the technical help the most.
Yes, I think we are together there. So in order for us to have this sustainability in terms of infrastructure or road development, one of the things that we'll have to do is to advocate for a conducive environment where engineers can also go out and work for all these municipalities. Like, for example, we could have all technical services managers in all municipalities as professional registered engineering practitioners with the relevant skills. But that's something that as CESA and together as engineering leaders, we must advocate for because we're not going to be able to achieve sustainable development if we don't sustain skills, for example, in municipalities. The next question is about society.
Oh, sorry, Godfrey, I think what you said is so good. So if consulting engineers of South Africa, and I think that, while we have all these webinars, we need to have concluding remarks that we take forward. And we need our best as CESA to make these statements out there so there is a change through constant reminder of why it's needed. And I think the DBSA model is a model to be used in these local municipalities. And you're quite right in enforcing, if you want this money, it comes with this. And these are the people that will help you spend it correctly and build resilient infrastructure back after the event of a devastation. So I will hand a note to you to take it forward. Thank you, sir.
Okay, it's a recorded. We'll take notes. Okay, the next question is from society, the balancing act, because we're talking about reducing carbon emission. We've got carbon reduction objectives. But on the other hand, society are just looking for a road. So how do we balance this? That we are engineers not only of sustainability, but engineers that are also delivering affordable and basic services to society. And maybe the ESCOM situation comes handy here. What do we do? Do we opt to go for carbon reduction and then we don't have electricity? But I'm leaving it to you. How do we do a balancing act? As you are advocating for sustainability, how do you also advocate for society?
I think that's the toughest question. But I think you can't not provide the service. That's the first thing. And I would limit the exposure to carbon emissions by using clever solutions to build a road in rural areas that could be labor intensive. You could use less, and it could be to the benefit of communities where you use labor intensive construction methods, LIC, EPWP, and then you create employment. Because the just transition strategy says you can't leave communities behind because you're going to build high order roads and using big technology. So you can't bring machines in where you can use labor. So still producing less carbon emissions, but doing labor intensive. I'm using that as one example.
Yeah.
But also you can't come with principles in areas where rural people don't have the benefit of education and technology. So it's a matter of being sensitive to them in a proper stakeholder engagement of understanding what your intent is and how you're going to get there and bringing them on board early. Because the just transition is very clear to not leave people behind, to not use infrastructure or construction methods that will limit labor intensive means. Create labor intensive construction methods. So you create employment, you create jobs, but do it in a green manner. And I think there's ways of solving that without not building the infrastructure, not providing the water, not providing the roads, not providing the clinics. It definitely can be done through innovative means and solving the problem between the compromise of social economic needs versus development needs. And
Okay.
we have clever engineers. This country has a lot of clever engineers. I mean, we say there's a brain drain. I don't believe in it. I think our engineers are so competent here that there's definitely solutions, and some of it I've mentioned in my talk. But there's cleverer people than us that know how to design greener instances, but also providing employment opportunities.
Yes. Okay, this is the last one now with the committee, the Quality Risk and Sustainability Management Committee. This session today is a webinar part of the best practice series, which is great. I think it's a great initiative by CESA to come up with practice notes. Can we expect a practice note or two around the topic of today, but also maybe including the other elements, society, procurement? I don't know, within the committee, are we working on any practice note maybe that could be issued for members to comment and then be published later on?
I think, Godfrey, absolutely. We are very passionate about change and climate change and how we adapt or mitigate towards it. I think these webinars are excellent, but as you quite rightly said previously, we have to have practice notes and have to initiate change through the practice notes so that we follow through on what needs to be changed at a higher level. So these practice notes will come through, and I think it's a great initiative from CESA to actually ensure that we are well equipped as consulting engineers to drive the change. Because as you said if you look at my past 2080 slide, it needs a collaboration between the public sector, which they are busy doing now. They are actually working on changes to design standards and documentation. And we must be the implementers of the design in terms of how we go about through our practice notes and our standards to help this change in a collaborative manner with the supplier and the contractor and our stakeholders. So yes, watch the space for our notes.
Okay, many thanks. I think, Mahendren, let's close. And I would like to close by saying many thanks to you once again, Mahendren, for sharing your expertise and practical perspective on sustainability and decarbonization in the road infrastructure. And again, a sincere word of appreciation to the CESA Quality, Risk and Sustainability Management Committee for conceptualizing and delivering this important webinar as part of CESA Practice Note webinar series. We also would like to thank our members and inform everyone that the practice notes are available on the CESA website, on the member sections. They are only available to members. If you can't access, you can send an email request to general@cesa.co.za. So finally, many thanks to all the participants for your time, for your comments, and really for remaining. We were not sure when we were done with the presentation whether we will still have a number of people participating. Thank you very much. And on behalf of Consulting Engineers South Africa, CESA, my employer, we wish you productive afternoon ahead, actually the whole year ahead. Thank you very much and goodbye.